Take it slow, but it's not typical. He already knows that my love is fire.
So now we're going over logarithms and their derivatives. So a logarithm, just to review real quick, let's see. So we have a graph. Here's 1, 0. And we have something that goes up like this and out. Okay, so this would be like f of x, something to the effect of f of x equals ln, good old ln, x. Okay, let's see. So then we'll just jump straight into the derivatives. So we have the derivative of b to the x equals ln b, and this is just a formula that, again, you can find in your book. Okay, so this is what we know. This is one of the theorems and our derivatives for b is greater than 0. Okay, so here's a nice example. So we have, let's calculate the derivative of 5 to the 2x. Okay, so according to this formula, our b is like 5, right? So this is kind of like b. So we're going to plug it in. So we have ln 5 so far times 5 to the whatever we had before, so 2x, right? And then there's a little bit of a twist because then we have to do chain rule, right? This is a function of x technically. So the first derivative of this is 2. So our final answer is 2 ln 5 times 5 to the 2x. Okay, so that's it for that one. It's pretty simple. Okay, alright, so now we have, this is another formula. So d dx of ln x equals 1 over x. Okay, that's a pretty fun one. Also, so this is assuming that there's a 1 in front of the x again. So here's the more general one where we have ln function of x equals, okay, so here we have kind of the same thing. So whatever is inside the ln is going to drop to the bottom. So we have our normal f of x, and then we have to implement chain rule again. So f prime of x times f prime of x. Okay? So let's see. Let's do an application of this one. Okay, I'm going to open a new slide so that I have more room. Okay, so an example would be, let's see, we have f of x equals x plus 1 to the third over square root x squared plus 2. Okay, so technically there are multiple ways you could do this, as in you could do quotient rule, but that would be kind of long and tedious. So let's do it the ln way. So we can use the property, I'll write it up here, of ln f of x equals the derivative over the original function. Okay, so we're trying to get to this. Alright, so what we're going to do, how we're going to approach this is take the derivative of the ln of this function. So we're going to ln both sides first of all. So ln fx on the left equals the ln of everything on the right. So like this. Okay, x squared plus 2. So all of that. And then the way we can rewrite this on the right is just to simplify it using the properties of logs. So this is equivalent to 3 ln x plus 1 minus 1/2 ln x squared plus 2. Okay? So then, from here, now we need to take, according to the formula, we have to take the derivative of all of this. So it actually isn't that bad, no, though, knowing the derivative of ln. So derivative d dx of ln f of x is now, let's see, 3 over whatever is inside, so 3 over x plus 1 minus 1 over 2, and then 1 over x squared plus 2, and we can't forget chain rule, so times whatever is the first derivative of the inside, which is 2x. Okay, so let me rewrite this a little bit cleaner. So now we have 3 over x plus 1 minus, and the 2's cancel, right? So then we're just left with x over x squared plus 2. Okay, and now we're not done. This isn't our f prime of x, because if we look at the formula up here on the top, we have, to get f prime of x alone, we have to multiply the original function over to the other side. So this, what we have, is on the left. Okay, that's that. So then we have to multiply this times our f of x. Okay, so let's go on to a new slide so I have more room to work. So now we have f prime of x equals what we just had, so 3 over x plus 1 minus x over x squared plus 2, all of that, because that was the derivative of our ln function, times the original function, which was x plus 1 to the third over square root of x squared plus 2. Okay, and now this is our final answer. See? So you see how it's pretty complicated? So this was probably the best way to go about it, I would say. Okay, and now for one last example, I'll explain something first. Now this has to do with integrating. So the integral now of 1 over x dx equals ln of the absolute value of x plus c. So again, this is just going backwards, as differentiation and integration do. Let's do a quick example, and this will wrap it up. So let's say we're given x squared over x to the third plus 1 dx. Okay, so here, normally we wouldn't, so you kind of have to recognize that this is an ln problem, or logarithmic. So our u could be the bottom, everything on the bottom, okay? So our du is going to be 3x squared dx, right? So then we're going to do u substitution. So we're left with, because we'll sub in the u for the bottom, so 1 over u, right? And then we still have our x squared. And then let's do the same thing as we did with the other problem. Let's get dx by itself. So this would be du over 3x squared, right? So if we plug that in for here, then we get du over 3x squared, which again is very convenient because the x squareds cancel out, okay? And we're left with 1 over 3, right? That can come out. Integral of 1 over u du. And now, from doing so many problems like this, you'll be more familiar with recognizing this as an ln. So this will just be 1 over 3 ln absolute value of u plus c. Okay? So then, I'll go on to the next slide again. And our final answer is going to be 1 over 3, ln of, and we said u equals x to the third plus 1, I believe, x to the third plus 1, and then our plus c. So this equals the integral of x to the second over x to the third plus 1. Okay? So that's our final answer, and that just about does it.